Hi, we're going to be talking about a kind of graph that goes very nicely with the two-way table, and that type of graph is called a segmented bar graph. And so a segmented bar graph is nice in that you can look at distributions that are shown in a two-way table in two different ways. You can look at the different subgroups, and then you can look at within each subgroup, what is the breakdown within the other variable. So it's a little bit like a bar graph that is blended with a pie chart. You know how in a pie chart you have a circle, and that circle represents 100%, and then you have like a breakdown that shows, oh, well, I have 20% this and 10% this and 70% this, and that's how I get to 100%. Well, a segmented bar graph does that as well. Each bar is measured out to be worth 100%, and then you show sort of a breakdown inside of that. Now, before we get deeper into a segmented bar graph, I'd actually like to take a step backward and just have us look at what I would call marginal distributions. So if I have a two-way table, I can make just standard bar graphs using this information, as well as making segmented bar graphs. Segmented bar graphs, by the way, are also sometimes called stacked bar graphs. I might actually accidentally say that, so it means the same thing. Okay, so there was a 4-year study reported in the New York Times on older men who are 70, older than 70, and they looked at their blood cholesterol levels, and then also if they had, it was all people who had had a heart attack, and so either they had a heart attack and survived, or they had a heart attack and they passed away from their heart attack. So this was the distribution within that study. Cholesterol level versus heart attack outcome is how I would express those two variables. And part A asks us to look at the marginal distribution for cholesterol level. So just like we talked about with marginal probabilities only use numbers at the margins, and they disregard completely one of the other variables. So since this is asking here for a marginal distribution for cholesterol level, it's saying nothing whatsoever about heart attack outcome, and that's fine. This is just a graph of one of the two variables. So I just did a little magical math there, and I totaled each of the columns and the rows. Now the rows I'm not especially going to be using in this particular problem because this question asks about marginal distribution for cholesterol level, and cholesterol level are my column totals, right? So I'm going to be using cholesterol level. I did total up the rows just to check my arithmetic. I wanted to make sure that the grand total was indeed 112, so I wanted to be able to check that math more than one way. So that's why I did that calculation, even though I don't strictly need it. Then, in order to figure out this marginal distribution, I'm going to take each of these categories and divide by 112. So 48 out of 112, and 37 out of 112, and 27 out of 112. And those are going to give me, those calculations will give me percentages. They will be kind of close to the counts because the total is 112 and percents are based on 100, so it's not going to be super different. In fact, I know, because I already did this off on the side before I started recording, this comes out to be 43%, this comes out to be 33%, and this turns out to be 24%. And so when I'm asked to find the marginal distribution for cholesterol level, I know, for example, that within this data, 43% of the men had low cholesterol, 33% had medium, and 24% had high. And I can represent that then in a typical sort of bar graph that would look like this. Okay, so my percents here, I didn't actually label this, but I was counting by tens. I did label that those were percents, and then I just showed each of those groups. Now, that's a fine bar graph, but it only graphs one of the variables, right? It only graphs cholesterol. I could do the same for heart attack status, okay? So let's think about how that's going to be similar versus different. in this data, since it's the same data, I'm still going to have a total of 112 men. What else will I need to do? I'm just graphing heart attack. So I don't care about the cholesterol groupings. I just am caring about the groupings going this direction. Right? So there's going to be 2 bars, and this total is 64, and this total is 48. So I'm going to do 64 divided by 112, 48 divided by 112, find my percentages and have the 2 bars. So I'd like you to pause the video for a second, find the percents, make your graph, and then come back and compare with me. Okay, this is your opportunity to practice when it doesn't quote unquote count, right? There's no big deal. If you happen to be wrong here, you'll erase. Not a big deal. But do practice so that you can get the most out of this lesson possible. Pause. Make the percents, make the graph. Okay, hopefully the graph that you made on your own looks something like this. The 2 percentages that you should have calculated were 57% and 43%. You should have a tally of some sort on your vertical axis. I counted by tens again. You do not have to count by tens. Just pick a number that you're counting by and stick with it. And then you should have labels for the 2 groupings of type of heart attack. Okay, so again, this is a great graph. It's very informative. However, it only tells us about one of the 2 variables. It only tells us about heart attack severity. It doesn't mention cholesterol. So that's where it's really nice to have your segmented or your stacked bar graph, because now we'll be able to show both pieces of information together. And you can actually do both pieces of information together in 2 different ways, which is very exciting. All right, so this one said calculate the 3 conditional distributions. Now it says conditional distribution here, not marginal distribution. So conditional distribution here means on the condition of having a certain level of cholesterol. So on the condition of being low cholesterol, so this will be my low, what is the breakdown of type of heart attack? On the condition of having medium cholesterol, what's the breakdown? And on the condition of having high cholesterol, what's the breakdown? So to figure that out, I have to go back up to my chart. I need to get these totals again. And then within each of these groups, I'm going to determine what percent I have for each kind of heart attack. So for example, I need to do 29 over 48 and 19 over 48. (29 over 48 is about 60%. And 19 over 48 is about 40%. So within my first bar, that's going to be my split. Now, since this is a stacked bar graph, all of the bars are going to have the same height, and that height is going to represent 100%. So make 3 rectangles, make all of them the same height, and then set up your scale to go from 0% to 100%. All right, now I'm going to do that subdivision of the low. So we just had determined that within the low cholesterol group, we had 60% that were non-fatal, that survived their heart attack, and 40% that unfortunately passed away from their heart attack. So I'm going to choose, and this is a choice, but I'm going to choose to put the non-fatal heart attacks at the bottom. Now, by choosing that, I'm going to make the same choice for the other 2 bars. If I had chosen opposite, then I would choose opposite for all the bars. So what I'm saying is put the subgroups in the same order within each bar. Otherwise, you're making it purposely confusing for the person reading the graph, and we don't want to make a purposely confusing graph. Graphs can be hard enough to read without us trying to make it more difficult. We should try to make it as easy as possible. Okay, so 40% of people who had low cholesterol passed away from their heart attack. 60% of people who had low cholesterol survived their heart attack. We'll do the same kind of computation up here. Okay, so now let's take a look at the medium cholesterol people. So I need to do 17 out of 37 and 20 out of 37. And find those percentages. And I got 46 and 54. So then I would put that into this bar. And then for high cholesterol, the same idea. You would do this division and this division, find the percents, and put it into the bar. Okay? I would again like you to pause the video and then come back when you are done with that aspect. Okay? You're going to find the percents, split up the bar accordingly, label, then you can look at the answers. Okay, so this is sort of a sloppy copy, but you can get the gist, okay? So all the bars, same height, and then you should show the breakdown. Since I made the decision to have my non-fatal heart attacks at the bottom over here, that should be what I did on the other two bars as well. And so this shows within each subgroup what happened as far as survival of heart attack, okay? All right, now, hopefully you've been thinking ahead and realizing, well, it's a two-way table, so we could do the percentages two different ways, right? So that was showing the breakdown of heart attack outcome within each cholesterol group. We also could do the reverse. We could take each heart attack outcome and then show the breakdown by cholesterol. So how many bars will this one have? You're right if you thought in your head right there that it should have 2 bars. There's going to be 1 bar for non-fatal and there's going to be 1 bar for fatal. And then within each of those bars, there's going to be 3 subgroups. Okay, so this should be what your setup is like. You should have 2 bars. Your tally should go from 0 to 100%. One of the bars is going to be non-fatal, one of the bars is going to be fatal. In figuring out our percentages, we're going to be using rows. Okay, so I want my total going across of 64 and my total going across of 48. So to do the calculation here, we're going to take each of these numbers and divide by the row total. Okay, at any point, if I am going too fast for you, feel free to pause or to rewind. Okay, so this is working out for my first bar. I'm going to do 29 divided by 64, 17 divided by 64, and 18 divided by 64 to get my percentages. And those percentages turn out to be 45, 27, and 28, approximately. I'm rounding, obviously. Okay? Now, for me, it makes the most sense to do the low on the bar, if that makes sense, like visually. So I would put, this was low, this is medium, and this is high. I'd put them actually in the opposite order of how I have them written right now, right? Low, down, low. So I'm going to go 45 up. Okay, so I went to the 45 and drew a line across. Now, this next part is what makes it a little more tricky. If you just have 2 groups, you draw a line, you're done. But when you have more than 2 groups, you look at this next one, 27. I'm not going to go to the 27 and draw a line there. That doesn't make any sense. This chunk is my low cholesterol chunk. It's already like that's done. I need to go 27 units higher than where I am now. So I could take 45 and add 27 to it. And say, okay, I'm going to draw it 72. And draw a line. I also could say, well, the top group has to be 28. So I need to go 28 units down from the top, right? And it doesn't have to be super precise, but it has to be within reason, you know? Shouldn't look completely just off because that's not a good graph, okay? But that would be like my low, medium, and high. And it would be nice to include the percentages on the graph. I always think that's a nice touch for clarity. So it looks something like that, okay? So I'm going to ask that you do the calculations for the other bar. You will do each of these numbers divided by the row total and get percentages, and then figure out where the lines go. Okay, I'd like you to pause the video and then come back when you have that done to check your work. Okay, working on your own, you should have gotten that 19 out of 48 is 40%, 20 out of 48 is 42%, and 9 out of 48 is 19%. And you can see my graph there. Okay, go in the same order as what you did on the first bar. And that's all there is to a segmented or a stacked bar graph. Offers us a way to look at data from a two-way table. Thanks so much.